Today we're going to be going over combinations and permutations. So first we're going to talk about permutations. A permutation is an arrangement of objects in a specific order. The order actually matters for permutations. So for example, we have the three letters A, B, and C. The permutations of A, B, and C would be ACB, BAC, BCA, CBA, and CAB, which for permutations are all completely different. However, on the other side of things, we have combinations, which if we have the same kind of setup, we have A, B, and C. AC would be equal to BC, and AB is equal to BA. For combinations, the order of the objects you have does not matter. And the formula for permutations is going to be the factorial of n, which is the total number of objects you have, divided by n minus r, which is the number of objects to arrange, and it's going to be the factorial of that. And what the factorial is let's say we have a number 9 here, and we take the factorial of 9. It's going to be every number multiplied together, including 9. So it's going to be 9 multiplied by 8, multiplied by 7, all the way to multiplied by 1. So if you want to look at that in just in a perspective without a number, it's going to be n factorial is going to be equal to n multiplied by n minus 1, multiplied by n minus 2, multiplied by n minus 3, all the way to multiplied by n minus however many times you have your factorial going to. And for combinations, we have the formula of the total number of objects and the factorial of those divided by the number of objects to arrange, the factorial of that, multiplied by the total number of objects minus the number of objects to arrange and the factorial of that. And on the next page, we'll do a couple of questions for those. Alright, so we have our first question, which is saying we have 5 books, and how many ways can we arrange them if we can have 3 books on the shelf? When I'm looking at this question, I see that we're going to see arrange. So that means that we're going to have 3 random books, so we're going to have 1, 2, and 3 on our shelf. But since we're having arrange, that means that our order will matter. Because if we have book 1, 2, and 3, but let's say we want to make this book 2, 1, and 3, this is a different arrangement of the books. Because I see arrange, I know that we'll need to use permutations. So we'll set this up, we'll have P, and then we need to have our N, which is our total number of objects that we're looking for, which we can see is we have 5 books. So we're going to write down 5. And then we're going to have the number of books that we want to arrange, which we can see is 3 books. So that's all done there. And now we just have to plug it into the formula, which is going to give us 5 factorial divided by 5 minus 3 factorial, which will give us 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 divided by 5 minus 3, which gives you 2. So this is going to become 2 factorial, which will just be 2 multiplied by 1. Now if you want, you can see that there's 2 multiplied by 1 here, and you're able to cross them out just so you have to worry about 5 multiplied by 4 multiplied by 3, or you could just put this all into a calculator and let it do it for you. But I'll have it do this, so we'll have 5 multiplied by 4 multiplied by 3, which will give us 60. And there's actually another way to do this question. So there's a button on your calculator that should look like N, P, and R. And what that button will do is you'll have to input your N first, and then you're going to be able to click the P button and then input your R, and it'll give you the same answer, and it'll do this formula for you. So if I was here, I'd put in the 5 and the 3, and your calculator should give you 60, which means that there's 60 ways to arrange 3 books out of 5 on the shelf. Alright, so now we have our next question, which is saying let's use the same 5 books, but now we want to know how many ways we can choose 3 of them regardless of order. So because we see that it's regardless of order and that we're choosing 3 of them, that means we're going to use our combinations, because we're not going to use permutations here because we couldn't care less about the order of the books. So same thing, we're going to write down our big C, and we're going to write down our N first. And we'll see that we're still working with 5 total books. So our N is going to be equal to 5. And then we're going to be how many objects we want to work with, which we can see here is 3. So we'll put down 3. And now just fill this in with the formula. So we know our N already is 5, so we'll have 5 factorial divided by, we know our R is 3 factorial, and now we're going to have 5 minus 3 factorial, which will give us 5 factorial divided by 3 factorial multiplied by 2 factorial. Now you can put this into a calculator to get your answer, but I'm going to expand it out a little bit more just so we get to see the full way of how it works. So our numerator is going to become 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, and our denominator is going to be 3 multiplied by 2 multiplied by 1 multiplied by our new factorial, which is going to be 2 multiplied by 1. And as you see, we have this occurring once in the numerator and once in the denominator, so I'm just going to cancel them out, which will give us, and we see that our 3's are here too, so we could cancel out a 3. And now we're just left with 5 multiplied by 4 divided by 2 multiplied by 1, which will give you 20 divided by 2, which will give you 10. So if you want to do the question without a calculator, that's much easier to expand it out, because then you get to cancel a lot of the numbers and work with much easier multiplication. Or if you're allowed a calculator, you could just plug it into the original formula and that'll give you it right away. Now again, there is another button on your calculator, which is the NCR. And what this button is the exact same thing as for permutations. You plug in your N, you press the button, and it'll give you C, and then you type in your R. So if here, we'll put 5, C, 3, and this will give us the 10 we're looking for. So to summarize, we're going to say permutations. For permutations, the order matters, so I'll write that down. And then for combinations, the order does not matter. Okay, and a nice and easy way to try to remember permutations is by the P up front. We're going to have P, and so a word that starts with P that works with what we're doing is position, because the position of what we're working with matters. But for combinations, we're going to have our C, and with our C, we have the choice that matters. Not the order. Alright, and to wrap it up, I'm going to go over some things that will commonly be seen for permutation questions versus combination questions. So for permutation questions, a lot of the things that you'll see that require order will be password questions, because if the order didn't matter in a password, then it wouldn't be a very good password. Another thing is race, because in a race, everyone still finishes the race, but the person that ends up getting picked first and getting the first position will let you know who wins, so the position would matter there. While for combinations, some things where it doesn't matter would be a committee, because if you're picking people for a committee, it doesn't matter who gets picked first or last, because everyone's still going to be on the committee no matter what. or are lottery numbers not for winning lottery numbers, but for picking lottery numbers. Because with lottery numbers, it doesn't matter which number goes where as long as you fill out all your numbers.